Welcome back, everybody. We're going to finish up on this Ender 5. First, we're going to go over everything I did off camera, keep you informed, and then we'll finish it up, do a couple of prints probably, and a little bit of resonance tuning, and it's ready to go. All right, let's kick over to the printer. All right, over on the side camera. 1 second, confirm, yep. YouTube says we're working. All right, still don't trust the streaming system. Okay, so last time we were working on this, and I left you guys in the last video, part 3. We were having issues with the LCD. That actually only took me about 20 minutes. I only had to look at 3 different examples of people's configs before I realized, yeah, I was grabbing the TFT version. Grabbed the default one, and it's working fine. I had the name right, but the actual pinouts were referencing, the ones I kept grabbing had the actual pinouts referenced instead of the extra config, which Clipper now adds. So usually that covers this encoder, I believe, the beeper, and the LCD, and SD card. I believe, if it is mounted on the screen. Not applicable to the Ender 3 screens. So, swap that out. Keep my ugly mug out of there. Try to get this as close as possible. So, it was a bad 3D touch sensor. I knew one of them was bad, so of course that one was bad. And actually, he is right there. Didn't even bother to remove it. So I just plugged the other one in. Yeah. And then I tried to home the printer. And it didn't make it. It bottomed out on, whoops, there went the bearing. That guy. This little lead screw support that was supposed to go back here in the back. Right chair. Yeah, cuts right into the height of probably about a millimeter for what the heat bed actually needs to home all the way to 0. That was kind of surprising, so I had to go ahead and take that off. I did also notice the lead screw, who installed it last time, which I should have checked beforehand, had been dropped all the way down in here to the bottom and was resting on top of the motor. So I went ahead and loosened this up, pulled it up a little bit, resecured the coupler that gives me, you know, about a millimeter or more at the very top, which doesn't hurt, because it was going right to the edge to zero the bed out. Also, vibrations end up traveling up through this lead screw if you have that sitting directly on top of that motor shaft. That is why it is a split coupler. One of the reasons, besides mating different sizes. So then, okay, we've got it. Let's try to home it again. And it bottoms out. I mean, right at it at the nozzle. I'm like, that can't be right. What is going on? Same bracket I've used on another Ender 3. Like, that just does not make sense. So, did a little research, compared between the 2 different printers, and that's when I realized this is version 1, I believe, of the 3D touch sensor, and on the other one is a version 2 or version 3, the one that has the actual plastic plunger. This is the aluminum plunger. The plastic plunger being the advantage of it can, if it crashes into something, it's just going to bend the end of the plunger and you can actually bend it back. Or they sell replacement ones. I have a whole little 5-pack of them. Although I haven't had to replace them yet, even though the first time I used the plastic one, it crashed and bent it. So I bent it back. Besides it being plastic, it also has a longer throw. So this pin actually extends further on the newer version than on this original one, which has the aluminum one. So there was my problem. So it's just not far enough to be triggered before the nozzle crashes in. So then I looked around for another bracket, and I could not find a bracket that easily stated that it was thicker than this one, or if it was thicker, it had a nice way to route the cables, or it wasn't just being held on one screw, or it didn't require you to take this bolt out or it covered up all of this, which, you know, that would make sense. Put a little strain relief for this too. Not against that. I just have other things that need to go up here that we'll discuss later. So that wasn't an option. So after that, I cheated. I just swapped out my two 3mm screws up here for longer screws and put a nut in between here, the 3D Touch, and then the nut on the bottom. And that actually gives me just enough of a standoff to cover and clear out of the way. That was an issue on this original one. I remember previously it crashed many a times. So that plastic plunger is an improvement, but was not expecting that. So did that, then at home's fine. Spent a little time, of course, calibrating the Z offset. Got a little too close the first time. You'll see on the print bed. That'll come off. It's pretty good now. It does need a couple more fine tunings, but I'm just going to run it a while, see what happens. But it works fine. Everything's adhering fine. So I had to take that off. LCD, touch sensor, and that is it. That is all we have changed since we were streaming last. Yes. Yes, that is it, I believe. So, then we did some test prints. Here is the first print. I don't know if I can get this any closer. Not with that height. Make that a little easier. There's the first print. That is a 100mm calibration cube. Oh, there was one more thing. Ha! Yeah, this is not the first print. This is the third print. Because when I started printing, I kept having issues with the filament adhering to the bed about 3mm up. And I thought, well, that's odd. I did just recently get this G-Tech PETG. This is a white PETG. I didn't even use the correct profile to slice it. I just used another one and threw it up there. And that's when I realized that in the clipper profile or clipper config for this lead screw, you have two options. Luckily, I came across this in a GitHub issue, so it wasn't much of a struggle. But these can be a 4-turn or an 8-turn, depending on when they were released, apparently. This one was set at 8, and it is a 4. I think that's correct. Or vice versa. As soon as I did that, this was the very next print, and it printed flawlessly. I've hit it with the calipers. It's pretty much right on 19 by 19, about a 0.5 millimeter short on the top, which is kind of surprising. I'm gonna let the thing run a little bit. We'll see if that smooths itself out. That is kind of odd. There's not much more adjustment I could do except maybe make this a 4.1 turn or something like that. I don't even know if that's possible. We might have to, or 4.0.112. So that was the first print at 100mm. So decent, nice. You can see a little bit. Well, I know I can see. I don't know if you can see the edges. Yeah, you can kind of see it. How the edges are a little bit horned. So we definitely have some flow issues going on there. So that was the first one. So happy, joy. And then here is the second one, which this one, you will definitely see a defect right about here. And that's where I kicked this up to 400% speed. And it's still printed fine. It did shift. As you can see, it is noticeably wider on all 4 sides. But besides that, at 400% sped up, fine. Top isn't pretty, that's for sure. And if you compare it to the other one, that is definitely much nicer. Much nicer. So, we resliced it again at 700mm per second. So this is PETG, I believe right about 230 is what it was printing at. Sliced at 700mm per second. Probably the fastest I've ever printed. And there are some defects. You can definitely see, like, there were some adhesion issues here on the bottom. on the back here. It's like some under extrusion, then over extrusion, but then besides that, and some burning. Then past that, the rest of it is pretty nice. And I actually did, right before I printed this one, I went ahead and did one pass of resonance tuning with an ADXL and the flow advance. And as you can see, or pressure advance, one side looks horrible. That was actually this side. That has to be a cooling issue. I'm not too sure why, since every other side looks fine. It definitely was getting covered by the fan. Whoop, side's there. Looks pretty good. Not much difference in the corners. I can see very little. But I went ahead and just chose right about dead center, because that's actually where it looked the best to me, and plugged that into the clipper configuration, and then printed that 700mm. So there's been some minor tuning. It definitely needs some more. So, but that was also with the ADXL tuning, was with this guy just hanging there like that. So that's definitely not good. So we're going to remove this and all the wiring. We're going to secure this connector right here. I was going to chop the end off and solder the two ends together like I did on the other two wires, because I have had issues with that losing contact before. But we're going to cheat, and this is not going to be a long-term auto leveling sensor on here. We're going to go with the clicky probe or something similar, and we're just going to heat shrink right on top of this, and that should hold that connector together nice and fine, especially as little as this thing's jumping around. Yeah, so we're going to swap those wires out, re-zip tie all of that, and then we will do the last little bit of cleaning up on the wiring and then some resonance tuning. So let's get started on that. Clippers. And you know, I just knew as soon as I put all this on there, I was like, yeah, let's test it first. Always test your wiring before you secure it. Right. I've also decided that we will be replacing this Capricorn tube. It's just slightly too short. I did find another bracket too. I'm gonna evaluate for turning this stepper motor. Kind of moves it out and 90 degrees, so the whole butt of the motor is inwards, but still doesn't come inside this actual frame, so it sits out and kind of shifts over. So it does put it more in line. It'll make it easier to get to the lever here, even though it hasn't been an issue yet. I'm sure it's going to be. We all know how it is. That's whole extruder, not the motor, but the actual gear system. I'm going to replace with double geared or Bondtech or something like that. So I will just deal with it for now. All right, we have those wires clear. Let's go ahead and pop this guy off. All right. So let's see what I'm doing. Not sure what is wrong with this one. Probably a broken wire or something minor, but it is also the old style, so we will not be using those again. As much as a game changer as these sensors were, I have to agree it's overcomplicated. My only concern with going, say, like the clicky probe or one of those, is the quality of the switches can be misleading, I guess would be the term to say. Some of them are 1,000 press, some are 1 million, some are like 10 million, and that actually can add up pretty quick, especially if you're double tapping and trying to get really accurate. That could add up pretty quick, and if you don't have spares on hand, that's going to be an issue as soon as you're ready to print something really quick. Also, before we go any further, if there was one modification that I would do to your Ender 5, there we go. I feel awkward not talking to y'all and not knowing y'all that there's a human here. If I was doing one modification, $0 modification, just in the short time I've had this printer and the limited amount of hours I've put on it, this crossbar modification doesn't require any extra hardware to work. You do need to get some extra M5, I believe it was by 12 millimeter screws to do the extra securing, the 2 on the back, 1 here, and then, well, I'll do over here, 2 on the back, 1 here, 2 on the back with T-nuts, 1 here with the T-nut, and then right down here on the top going down, even though I did have 1 spare screw over here. Actually, that one, not sure which. To secure down in the top. Using the stock screws off of here, it is 100% solid. I would pick it up and carry it by that. I do like the concept of having a little extra mass here in the corners with the metal, even though it's not a lot, and securing in more spaces. It just, I've noticed that just helps more and more. But just getting it down that much, be able to see, for one, your first layer prints, it's worth it. It's totally worth it. Gotta quit looking at the monitor, look at y'all. It's totally worth it. Secondly, if that was the only modification I did, and I did not have an auto leveling sensor, that makes the paper method for leveling your heat bed for tramming so much easier. So much easier. Previously with the bar right here, you're just in between, and it seems like right at the perfect, it's catching the paper, and then you're like, well, am I bowing the paper? It's just not worth it. Or you're having to do over here on the side, it's just not worth it. Game changer. To me, that's a game changer. Second modification I would say put into this printer if you're going to do it is upgrade, like all the Crealities, the big Tree Tech E3 Mini version 3. It's just such a good board, so easy to work with. The fact that you have temperature control over all the fans, it's worth it. Luckily for this one, I did not pay anything. I used Amazon points and it was on a special for like $35. So hey, and then of course, auto level sensor, and then we all know flex plate. It just makes all the difference. You can see where one of these cameras I'll get in front of. There we go. Printed too close. I'm just going to keep printing on top till it pulls it off. I already pulled the rest off. That makes all the difference in the world. All the difference in the world. Downsides to doing these modifications. The one that I'm still on the fence about, even though I know I'm going to stick with it, is moving this electronics case to the back. There's nothing wrong having it here where it originally comes. I still think you need the foot risers to get that extra airflow. This just seems like a bad idea as low as it was to the ground, and it's just blowing hot air right back into the intakes and around the sides where it's sucking right back in. So that just did not make sense to me. And oh, my mic stand. Oh no. Bear with me. I've got to print an adapter. That is twice this thing has come loose and just come right off the table. There we go. And then I will break. I have a little screw, printed screw, which is holding my webcam on. I will break that again. But I have a backup. So, this on the back. I like the cleanup of the cabling. I really do. It made it much cleaner, much nicer. It's much easier to work on, I think, being able to just hinge it open and get into everything. The downside is this fan is now coming right through, as well as this one. Not a big deal. This one only kicks on when it's at a temp. This one runs 24/7. I don't know if different batches of these printers have different power supplies and they are on a thermistor that only kicks on at temp, because I have some that do that and some that don't, and it's I can't tell you what makes the difference. But yeah, so that is on the whole time. So that is definitely much louder, blowing straight at you. It has definitely made me consider drilling 2 holes in this case here and also over here, and put in a little shroud. Maybe I'll just have one big one that covers everything. I could even just VHB tape it on there, just to blow straight up. once we do a panel on the back, that will definitely cut out some of that noise and direct that hot exhaust air straight up and out of the way. Just for now, that's loud. That's loud. You will not hear it once this fan kicks on. I don't know why, but it seems like it is way louder than it was on the stock board. So that is different. And while I am rambling, let's go and grab our zip ties. Finish up this cabling. But yeah, this crossbar, that I'd seen it before I ended up with this printer. And then when I got it, I looked at it, and it just seemed superfluous. I didn't really see much of a point. But after doing it, yeah, it just makes so much sense. I am sure some of the other modifications I've seen that actually take this and cut it and move it down in here is a better option. It looks more Voron-esque, I guess. But I don't like cutting stock parts. I know it's just 2020, but it only gets more and more expensive. And there's just no point. And then if you don't like a modification, you can put it back to stock and sell the printer as stock. Somebody might not like it. You never know. Alright, let's secure this wiring. Actually, before we secure it, let's go ahead and shut the power down. Do this wiring connector. I don't know if I can get a better shot of that. Let's make sure we don't screw up the wires. So here, so blue is going to orange. I so cheated on this connector. I just took, this is actually LED wire, and soldered some pins on there, 3 of them. Stuck it in. So we're going to put our heat shrink over. This is the right size. Make sure we don't put this backwards. Blue to orange. It's now in there. Nice over the center. Okay, Mr. Bick. Definitely not going to shrink down nice and clean over the individual wires, I don't think. I'm more just concerned about the connector in the center. Try not to melt anything. That's not too bad. Woo! That's hot. Definitely now has my fingerprints embedded into it. Oh, it's cleaning. It's shrinking not too bad. Yeah, that'll work. One side definitely looks a little better. There we go. That should work. Heat shrink should hold that in place. Lighter. Two-wire setup is so ugly. Once again, it is temporary. Do not like how tight this Capricorn tube is. Do have some other tubing, but it's not Capricorn. Just not going to do that to myself. This guy with his connectors, it's quite important for us to connect all together. Make sure our zip ties are all exactly the same. So I ask Steve. Steve builds. We'll leave a comment, and I'll have to redo it. So not pretty. And I am only zip tying to the wiring bundle. As I said in the previous video, I'm not even going to try to feed this through the wiring bundle. It would be different if it didn't have any connectors on the end, but it does. It's not worth the frustration. Something that's temporary. this one. Uno mas. There. Screw up the very last zip tie. Okay. The only problem with that is we did not run it on the right side of that. So yeah, we're gonna have to pull that open, clean that up. Wires actually, because I was in a hurry, sitting outside this pulley, we're gonna have to open up the case, disconnect it, run it behind here, secure it down here on the back, plug it back in, close the case back up. Not a biggie. Hey, more content. Way. Zip tie out. Go straight back over to the side camera. There we go. Not the prettiest, but like I said, this is not a long-term sensor. It's fine. Yep, that will work. So let's disconnect the power. USB cable. Need to print some cable hangers on the side of this desk. Let's come back over here. Let's knock everything off the desk. Let's get the keyboard out of the way. Need to print a keyboard stand for that. Get these printed parts out. Send them to you. We don't need them. All right. Let's go ahead and take the case off. Is it working? Hey, it's working. I've swapped this camera out. Hopefully it's not going to die. It was hot. Notice the your live. It's a little green LED on this camera. And I have 3. Even though they all look exactly the same, they come up with different names when you plug them in. Cheap Chinese cameras. They mostly work, but that one was yeah, the green light said I was live had gone out, and it was really hot. So it's overheating, or maybe there's a bad capacitor of some kind in there. I don't know. We will hook it up to another computer, see what happens. All right, second screw out. Here is definitely a problem. Get our handy stand there. We're just gonna pull this back. Yep, there's a problem. That'll work. As you can see, that's at about a 30-degree angle. These cables are just slightly too short for that to come easily back. So, yeah, when we go with the clicky mod, they'll definitely get extended if we aren't doing CAN bus by then. I don't think we will be. Start over here. This guy out of my way. There we go. It's a little less useless. I know in my heart I should replace those cables. These cables right here, but no, sir. It's just not worth it for something that's temporary at this point. I will just deal with this little bit of frustration. Just make this Allen a little tight. So close. If I was a smart man, I would just grab my bit. One bit out of my nut driver. Done with it. Or grab the ball ends, which I don't like using on these. This is exactly what we get when we're reusing parts. If this had been a fresh sensor, I 100% would have made whole new cables. And hey, we're going to look at this as an opportunity, because we wouldn't have found out about this until the first time we needed to get back into this case down the road. And then of course what would have happened is we would have opened it up and then just dropped it 90, and it would have ripped the cables right out of the board, probably ripped the pins out of the board. Go. This fan cable. This guy's out of the way. Pop this sensor loose. Our new little protected hole. Oh, take the protector with it. Okay, that ended there. There's that other motor cable. I think we have enough. Stick one more of these right here. Not necessarily for the sensor cables, but for the motor cable. There we go. It's fully supported. No chance of sliding out. Right in there. Go. Probably should have those clips 180. That also gives us this opportunity. This guy up, I believe. No. There was a reason we had that like that. That motor cable is slightly short. That's the other thing, this other bracket I'm looking into for this extruder, is it will give this cable a little cleaner path. All right. This is probably going to be the hardest part. Feed this back through. This is where we rip one of the connectors out. I'm going to remove the display just to make it easier. Which direction we got to go. In, that is in. That back. Oh, we missed a zip tie back here. Screwed up. Cabling. Fix that. Get this guy back in. Plug our fan in. look like anything is going to be rubbing on it. Next to the side slightly. Go. Take it. One corner. Second corner. Third corner. Yep, that's a pain in the butt. There's enough room, I could just do that. I'm stupid. Go. This one in. There you go. There you go. Take that. Right. Turns on this guy, get him secure. Almost. So close, so close. There we go. Right? Yeah, scary. It's out. Back up in here. But these all don't get pinched. Yep, everything is out of the way. Two case screws back in. Hold this vertical. Lucky over here. You know, they make face tracking cameras. I wish they made hand tracking cameras. That would be much more handy. The handy hand tracking camera. It's really amazing how different your hands look on camera to you. They don't look like that to me in person. Is that cancer? Is that cancer? If that's cancer, let me know. I can't do anything about it, but let me know. Give me something to keep me up at night. This wiring on the back. All right. There we go. I do think we're going to add one more. Don't think we need them anywhere else. Yeah, I'm happy with that. Put one more of these right in here. I don't break it. Go. Should keep everything nice and out of the way. I really like that. Just gonna push this excess cable back into the case. Be fine. All that's out of the way. All that's clear. Okay. Not perfect. Not the prettiest. It's gonna bug me. But as I keep telling myself, it's temporary. For 2 years. Okay. Let's flip this guy. Make sure we got clearance on everything. Yes, we do. Yeah, it's just slightly short. Oh, that ain't too bad. Going that direction. We're going to throw more of these guys on here. Right in here. Too close. Okay, there we go. Happy with that. Actually, possibly, let's try this. We haven't used these clips anywhere on this build. Let's see if they will work. Yep, like that better. This goes away. Woo. Ah, we broke one. Oh no. Oh no. What shall we do? There we go. Yeah, I do like that better. That is much cleaner. Just pop that right in there. Spread this one out a bit. There we go. Pull the stringy off of there. That is all of that. Taking a look here. Right, that looks like it. Spool is sagged a little. I'll tighten him up. Oh yeah, that was definitely not tight. See how that holds up. Definitely see that cracking in the middle of the night. Oh, so it fell off. The same thing that always falls off. Spool cover. Go. Good. Yeah. Extra screws out of the way. I think that's it. Don't ask me why I have my tablet over here with scene control and I'm still using my mouse. I am mostly happy with that. It's not as orange as you really think. She likes it. All right, so let's plug the power in. Front. Let's put our USB in. And show you all the details, but let's put our ADXL sensor on the top. Don't think I have a spot to give you a good shot of it. Just move this over. Okay, that works. So we have our ADXL board just on this little bracket that I found on Thingiverse. Actually has a screw hole in the back to secure it. I really don't think you need it. It is so tight. just does not move. That is connected just to a piece of Cat 5 that I've stolen the wires out, and then that is hard soldered because I was in a hurry, onto a Raspberry Pi Pico, which is plugged into my quad-core Celeron multi-instance Clipper server, which is going to be running 4 printers, this being one of them. This will be the second on that. Yes, second. Yes, till we get to the next one. So that is plugged in there. Let's go ahead and turn the power on. It's in, and y'all have seen it. I'm just gonna move. We'll leave it right there. I got enough room. Bring my browser up. So if we go over here, I hope the mic's still working, to the browser, you can see there's a Raspberry Pi Pico, which just is plugged into the ADXL, just with a longer cable. Yeah, it's just the cable I had. Not happy about it, but it's worked. I don't know if it's possible, if somebody out there in the community knows. Currently at this point, we do our testing with the Resonance ADXL, and then we take it off or leave it attached to the bed or somewhere. But we're not actively compensating with it in real time. We take an average with the testing, which we're going to run through here real quick, plug that in, but I don't see that as and granted, and you do some work in that to get it as smooth as possible across a curve of speeds. But I really think the next step would be having this, and with CAN bus, I don't know why we don't, the ADXL already in there, and then just actively measuring and compensating the entire print. Because some areas are faster, some areas are slower. Depending on the movement, if it's going diagonal or just in a straight X or straight Y, I could see that making a big difference. So I'm waiting to see that. So let's go. We have it in there. We have it mounted. We have done all of this. Off camera, we did that. We have pretty much this added in an ADXL file or in a config file. Let's reconnect. This is where it will never connect again. That always scares me. All right. Come over here to machine. You can see we see our MCU, which is the actual main board. And then we can see ADXL, processor usage. And then our Clipper host, which is running Ubuntu, using a whole 4%. So it is there. We need to come over to, yeah, mouse is acting crazy. To the dashboard, we're going to be doing some console stuff. Let's come back in here. Not what we wanted. We go here. So we can see it is communicating. It is working. The config has been added. This, to me, is the hardest part of this, is finding their commands in here. I kind of wish they were color-coded. So we'll copy that. We'll come back over here. We're going to go ahead and home everything. Try not to blow my vape right through the camera shot. I'm going to do that again, just so y'all can see I've sped the printer up a bit. Get this guy. Hey, there we go. Now I can't see what I'm doing, so that is relatively center. Let's go back over into the browser, and I am going to test the X. You can see it is test_resonances space axis equals X. Got invalid ID. That has happened before. We're just going to paste it again. The first time I run this, it usually seems to have a problem. And there we can see it's starting to test. So let's see if I can get a split shot of this. There we go. Now you can see what it's actually doing. It is moving. It is moving. So it runs up through the frequencies. All right, 80. And for the testing frequencies, I just went with the defaults, copy and pasted. I can feel it on the desk. Oh yeah, this thing is humming. Really should have done this in a different order. Put the new main board in first, got Clipper on it, did the ADXL testing, the resonance testing, so that way we had before and after. See if these frame braces are helping. But the fact I can feel it vibrating in them. Oh yeah. All right. There we go. It wrote to the CVS file. So now we're going to do this again. This time we're going to do Y. And my keyboard is too far away. Y. There it goes. This one gets a little more violent. And y'all probably can't see it, but it is just shimmying back and forth. Definitely much more resonance in the Y direction than the X, as would be expected with the way this frame is designed with this 2040. Glad I put the frame braces on it. I still would like something at the top connecting here over to here. Just give it more this direction, front and back. There it goes. Now it's humming. And we're past the hum. That's our peak resonance. '86, 87 hertz, 89. Oh, I can hear it. Oh yeah, right at 86, 87, it was really resonant. It has gone away. 110, 111. I am wondering slightly, I might do the math on this. I am an audio engineer, so regularly you have this same kind of occurrence with frequencies in this range in rooms when you are EQing a room. And the way that we get around that is because you put sound in a square box, and the frequency is equal to the length of the room on one axis or even two axis or three, you get a standing wave and it doubles the power of that one frequency. So we tend to cut that frequency out of the mix so it's just not overemphasized. So that is, and you can walk in a room and go, hey, this is a 150 foot room. Yeah, 150 hertz is going to have an issue. And when we pink the room, which is putting pink noise, much like white noise, in there and measure it, you can see that on the graph. So I would like to do the math and see what the length of these and this extrusion and the feet, if that actually matches up around that 95 to 97 hertz that I was seeing. Which I'm 95% sure it does. Okay, it has written the CSV file. So come back over here. Get this camera out of the way now. Made all these pre-scenes. I use none of them, and then consistently I just have to create one on the fly. That's the great thing about OBS. All right, go back over to the correct browser. Go. So let's go to the second point. Like how they say, make sure they do not become violent. All right, now we have to run these two commands right here. It's gonna be the first one. And for this, I believe, yes, we have to go into SSH. Let me open that up, get connected. Totally forgot about that. Let's make sure you can see it. There we go. Hopefully we don't have to use any keyboard. Oh, we've got two copies open. Hopefully I'm still in the right, you all are seeing the right one. We have pasted it in there. Let's hit enter, see what happens. Yep, it's running through. It is creating the graph for us. Interesting. Very interesting. So this is the second time I've run this. I haven't done, this is only the second printer I've done the resonance testing on. I have multiple clippers running. I just haven't had time. We did get a different frequency and a different smoothing shaper previously. I believe we had EI, and this is now asking for 2-hump EI. So there was their first for the X. It's also created the JPEG file if you want to look at it. I can't remember where it puts it. It tells me there. It is under a temp directory, which is going to be at the root. I don't care. I know I should be looking at that graph, but I just don't care that much. When we get to the fine tuning, yes. Whoop. Come on. There we go. Copy the second line. You do the Y. And enter. Okay. So there we go. That is using the same smoothing algorithm for Y as previously. So we have 2-hump EI at 66.8 hertz and EI at 66.4. So what we will do is remember this first number. We're just going to copy this. Except I have no keyboard. 2-hump EI at 66.8. Why is this? Come back over here. Make sure y'all can see what I'm doing. There we go. We're going into machine. And in my printer config, I have an include shaper config and ADXL config. So when I'm not using the ADXL, I can just comment out this first line and we're good to go. If I have problems with the input shaping, I can just comment out that shaper line. Good to go. So we're going to save and close. I didn't change anything. Come in Ender 5. I will show you the ADXL config. You can see that's very stock. We just had to find with an LS USB by device ID exactly how you find the main board, the actual Pico Pi added in there for the path. All this is just exactly out of their example configuration. So let's go down to shaper. And now we need the keyboard. So we can't remember what we had. Give some space. So we want 2 hump EI at 66. And as you can see, previously we're at 65.2. That's where I ran it last time, but that was with the extra sensor just kind of hanging off the front there. 2 hump. Sounds dirty. It's perfect for this channel. Delete that one. And we know this one stays at EI, but look at that. 76.2 is what we had previously. And this time we're going to be at 66.4. Right. Going to save and restart. Get the keyboard out of the way. Make sure we come back. Go ahead and search endlessly. We're going to remove the ADXL. Pull it off. We're pretty much done with it for now. I'm sure in the future I will be fine-tuning it 2 to 3 more times, especially once I get these extra screws and stuff in here. That will definitely affect the resonance. If I put any extra panels or any type of piece on here, especially up here, we for sure need to redo that. Also, when we go to linear rails down the road, we will have to redo that. So let's go back over to the printer. Let's try our 700mm calibration cube. There we go. Now you can see what's happening. If I know what's happening. It says it's printing. We are warming up the heat bed. We're at about 40 degrees, going to 70. Did I restart? I know I had to because I made a change. But, you know, I'm going to cancel this. I'm going to restart the firmware. Just want to make sure. Of course, it has to heat up all the way. Knew it when I did it. Let's just go over here, force a restart. Flipper Ender 5. Yes, restart. There we go. Now we for sure have those shaper settings in there. Let's print this guy again. There we go. We need to tighten this chair. Let's see what happens. So all in all, labor-wise, I'm not going to count the amount of time it took printing all these parts, because that's, we all know, secondary. They weren't too bad. And I did have some other stuff to print in the center. Cost-wise, we have spent nothing, at the most $35 to $50 for the main board. We really had to. I'm sure I'm waiting for the version 4. We also took the board that was in here, and it's now going on an older Ender 3 Pro that has a 1.1.5 board. That one is the next project. We're going to convert that over to the Belted Z. Slightly different setup than I believe Modbot did. I don't remember. Maybe the same. And we'll get that printer going and clipperized. Besides that, no extra money has been spent. We do have these 2 brackets left over. We have these 2 screws, which I did not have. They were too long to fit in any of these locations. We have these 4, which we're holding the electronics case in. There were 6 total. 2 of them I am using on these crossbars. And then the generic fan shroud that comes with this guy. And that's it. We will keep all those parts. It appeared to have taken me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 30, 2, 5, 35 3mm. Oh no, take that back. 35, 39 3mm, which I believe were 10mm long. No, I'm lying. 2, 3, 4, 5, 6, 7, 8, 20, 4, 5, 6, 7, 32 5mm M3 6mm, I believe. No, don't want to tell you wrong. I believe these actually went between 6mm and 8mm, depending on the thickness of the part. That's something always to remember. The thickness of the part and how that person designed it can make a huge difference on whether that fits. And I can't really confirm that on the. I believe the bottom was one board for 8s. I would just buy a pack of these 6, 8, 10, 12s, and 16s, because here on these braces I had to use. Those look like 18s. Yeah, 18s. And then I also used 18 here on the BL, or 3D Touch auto level sensor. Don't want to be a liar. Well, the skirt didn't hold too well. It's rubbing a little. We're going to let it go, see what happens. I did not, I think the bottom layer was at 100. I didn't want to go too fast on that bottom. Once we get past that skirt, we'll pull that out of the way. Prime line looks good. Does have a little bit of a bulge at the edge. Definitely tell we're a little high in this corner. That doesn't look good. We're gonna cancel that guy. Oh. Well, besides it not sticking, actually it was printing fine. Alright, we're gonna cheat a little. Once again, as I said, I did not get this heat bed totally Z set and bed pro totally set up, so let's just use some glue stick. Print again, we should be pretty close to temp. Let's see what happens. All in all, I was hoping for this to be a 2-day project. This would be day 4 at 2 hours each time. No, we're not to 2 hours yet on this, but so right about 8 hours. If you also look into off-stream time, you know, maybe there's 2 hours, 2.5 hours in there. Probably the majority of that is researching the parts to find what I wanted to use on this. And then what's actually there, because we've all been hit with Thingiverse where you're like, that is exactly the part I need. I'm going to click on that, download it. 404, not found, doesn't exist anymore. All right. We're almost to temp, ready to go. Aftermarket parts being entirely the main board, the sensor, the silicone bushings, and that be it. A couple ferrules for the power supply and heat bed and hot end cables. That's about it. Do want to add some trim color in here. I'm not sure if I'm going to go with the green or something else. We are going to add LEDs. May possibly do that on a stream. My first thought is putting one strip back here, going straight out. That's right across the print level that would generally need to be seen once this heat bed comes down a bit. All right, prime line looks good, which there's no problem sticking over here. I also have not done a height map, so it is not auto leveling. Oh, that skirt looks better. I can definitely tell it's still a little close. It's like in the 0.0 integer range. It just needs to be a hair thicker. It's a little tight. Yes, here I am looking from the side. I can't see anything. I totally forgot I can come right here to the front and look like you guys are. So much better. So yeah, strip of LEDs right in here in the front. Possibly, I may put some in this side extrusion. Shooting across as well, LED tape, because with it taped to the actual inside of the extrusion, I'm just going to have to actually take this extrusion off and slide it in with the backing off and very carefully remove the backing and stick it down in there. There will be plenty of clearance, so they're not going to get hit by the wheels. Of course, later on we will be replacing that with linear rails, so that is a consideration. I can't remember off the top of my head. I need to do some research. For the Mercury 1, I don't remember if the linear rails mount on top or on the inside. Possibly even underneath. If they're on the inside, that ruins that idea. But I would like a strip here on this side and a strip on this side. And then I am thinking doing the same thing right across here in this X carriage inside. And then it will be downward lighting this entire work surface except for right where the hot end is, of course. And that will make running the cables down with the motor cable pretty easy. Or I could even feed them back at some point along the top on the inside and come back up into here, but I don't like that. I'd much rather go down with the motor cable. There's not a lot of space to add any of, say, like the Voron style lighting kits in there. Just can't do it the way the printer's designed. Not until we go to the Mercury one. There we go. That's stuck perfectly. What is estimated time on this cube? Slicer says 26 minutes, 31 seconds. Of course, still changing, going down by that, so probably about 30 minutes. Clipper's estimate is 28, but that is dropping pretty fast. Well, going back up too. We're 5 minutes and 30 seconds in. I have PID tuned the hot end and heat bed. I believe I did 80 on the heat bed and 260 on the hot end. I don't ever expect to go that hot, but with the fans on, that's something to remember. What I like to do is drop the heat bed or raise the hot end away from the heat bed, PID tune the heat bed and the hot end, and then I like to bring them very close to each other, maybe a millimeter of space, kick the part cooling fan on high, and then re-PID tune both of them. That first one usually gets you closer. I've had issues before where I just tried to kick the fan on high and the original PID tuning was so off it just could not keep up and it aired out. So that first one gets you close in there, and then with that on, where it's constantly not only cooling the hot end and the heat bed, but you're getting that reflected air back and forth between them, and as well as that residual heat that's down here that's coming up that can affect. And that's the real world situation you're going to be in when printing. So to me, that is where the accuracy needs to lie. Not when it's, 6 inches up here, 100 millimeters, and nowhere close to the print surface. It's looking really good. I can definitely, yeah. It's pretty sad when being too close gives you more adhesion issues than too far away, but it is definitely just a little bit of elephant footing on those first two layers. Just a little. That's okay. That's looking really good. I for sure should have done this process with PLA the first couple of times, or a different filament. I don't want to say this is bad filament. This is G-Tech white PETG. Nice and shiny. Do have a feeling we're going to have to tune the flow rate slightly. I think the pressure advance that I did and flow rate, of course, go hand in hand. So I'll probably undo my pressure advance setting, retune the flow, a few more calibrations. My one concern with this, I did find multiple examples of Ender 5s that were clipperized. But all three examples had a different rotation setting for the extruder and where I found them for clipper. So that's confusing. They really don't say if they had the original extruder gears or an aftermarket. Usually with the aftermarket, you could pretty tell because the ratio is like half or double. triple, but not the case here. So not too sure. So I went with the slightly higher one. So it's probably under extruding slightly. Or over extruding, who knows? Also aware this is not the best cooling fan duct, but it is better than stock. And for me, it's the quickest and easiest to get the printer up and going. I'm so tired of going through all these different designs that, oh, okay, that's a wonderful design, but now I cannot use my leveling sensor with it. Let me find a different one or try to modify yours. I'm over that. It is fun modifying stuff and going through all this, but at some point you just want results. And I am a path of least resistance for the results that I get, and this has been the path of least resistance. All right, we're about, what does it say we're at? 25%. I am going to kick the speed up from 100% to 200. We're now at 200% with the same flow rate. See if we could make it fail. But so far, it has been printing.
Awesome!
Put into that, get a little better view there. So I blow my vape right across the camera. And I just realized I did not put the right thumbnail up for this video. I'll have to correct that after it's done. No failure yet. And I'm getting some little bit of stringies coming off the infill. So far, it does not look like it is overshot like previously was doing. Really would like to put the belt tensioners on here. I think that will make a huge difference. These belt tensions are pretty good. I would just like a little hair more control over them. So nice being able to see what's printing. definitely hear those little pieces inside, but we haven't had a failure yet. Going to give it a while, then we'll kick it up another 100%. Still at 200. Sliced at 700. I can already guarantee you that this guy will probably replace my clipperized Ender 3 Pro and my Tronxy X3, which is clipperized as well. Both those have linear rails on the Y, and the print great, but this is just so much nicer. The one issue I've really had where this style printer, besides better printing accuracy, really comes through is if you're printing something very tall and very thin on a bed slinger. If I can get my hands in here, very tall, very tall. On a bed slinger with it doing this, it's gonna move. It does not matter how much you slow it down. Give you an example. These little roses just didn't print great, but the stems, which you can tell right there, and then it just looks horrible. And what do you think I printed this at? 60 millimeters a second? No. 50? No. 40? No. 30? No. 20? No. Big old 10? Nope. 5 millimeters a second. Pretty much as slow as I could get it to print. And that was the best that I could get on a bed slinger. Didn't matter the amount of cooling. Anything. It just did not matter. This little piece, just as long as it is just the pressure from the nozzle, just enough to wiggle it around, and it just gets worse and worse and worse. This would be a great resin print, I tell you that. If I had a resin printer, I could have printed like a whole dozen of them, just straight out. I'll probably be what I do once I get a resin printer. So yeah, so on this printer, since your bed isn't moving, it's not a bed slinger, obviously. It's still going to be an issue because, like I said, just the pressure from the nozzle touching it was enough to do that to it. It should definitely help. But I don't have any women to give flowers to, so unless one of you wants flowers out there. All right, we're still looking good, 200%. We're going to kick it up to 300. There is 300%, 100% flow rate. I can visually tell where I sped it up to 200%. I can tell a difference, but it is, at least so far as I can see, only in the corners. So that means we got some more pressure advanced tuning to do. Really need some light, but I am not seeing any ghosting, any ringing. Did not have much before. And of course this white filament is not the best idea. I do see some scalloping in one of the originals. A little bit on the leading edge of X and Y. Let's check in over here. Just a bit on that one. Still no failure. Also, to add on to the resonance tuning, where this printer is placed, where any printer is placed, is going to make a difference. It is on a very heavy electrified standing desk right now, but I can feel the vibrations right now just running through it. I could feel them in the resonance tuning coming through. So once this goes back in its home, I will probably have to fine tune again, just because it's on a different surface. It's on a completely different surface. And unfortunately, this printer is pretty much sitting mostly on the ground. Check. Yep, all the wires are clear. Nothing is rubbing. The closest it could possibly have an opportunity is that motor cable. It's definitely not rubbing on the spool. Still need to get a longer display cable. I want to hide that cable underneath the frame. Don't like it on top. Yeah, really happy with how this turned out. I can see the LEDs now and have some clue if something burns out, if one of the MOSFETs shorts. You'll probably hear how loud these fans are now. What percentage is this print at? We're at 62. 70 will go up to 400. Still looking good. I can for sure tell the difference every time I've changed the speed. It does look like now that we're at 300. Layer does look slightly wider on the X and Y. Oh, it looks like we're getting close to the top. Yep, right in the Z. See what we're at. We're at 70. Take it up to 400. I'm not sure this is really fair since we're close to the top. Once we get to 85, yeah, 85 will kick it all the way up to 500%. Still at 100% flow rate. Really happy with these results. This is the stock hot end. I haven't even opened it, or I believe even changed the nozzle from when I purchased it. So I do not believe it's all metal hot end on this model. I'm not sure what it came with stock. I do have some others. If I do swap it out in the near future, I will probably go with the all-metal Creality one, not the new one, the high temp, as much as I would like it. But I have one of the knockoff ones that has the extra slots cut in the front. With the all-metal hot end, that is on my Ender 3 Pro that's clipperized, and it's perfect. Hasn't jammed once, hasn't clogged, have had zero issues with it. PLA or PETG. Zero issues. Even with the swapping back and forth between PLA and PETG, I'm notoriously bad about not getting it right up to a good temp and running some PLA through hot to try and pull that extra PETG out. I'm really bad about that. I have not had a failure yet. So for a knockoff hot end, I was pleasantly surprised. It actually seemed to perform better than my E3D V6 clones. And quite honestly, easier to mount. Way easier to mount. See a little bit of zitting on one side. Still no failure. 400, we're gonna kick it all the way up to 500. We're at 500% speed, 100% flow. See how bad this does to the top. Also, what I want to see, how much CPU are we using? So we are using a whole 6% of CPU on this instance. 7. Oh, there's a 9, back down to 6. So sliced at 700 and at 500% speed increase. Definitely not overloading this little quad-core Celeron all-in-one $80. It was literally $80 on sale. Mini PC with just a stock Ubuntu install and then 4 instances of Clipper. With Octoprint, I don't think I could have done 4. I have done 3. I did have this was an Octoprint server before, and I had 3 running. 3 instances of Octoprint with no plugins, fine. Once you start adding all the plugins that you need in Octoprint, well, you don't need, but you know, we need them. Just could not do it. I just had too many issues, and that's when I gave up on Octoprint. Unfortunately, I would like to see some more plugins for Moonraker. The time lapse is good. The one that I would really like to see is a streaming plugin like we had with Octoprint, even though I never got that to work reliably, which is why after trying that plugin on, there's several versions of that plugin, tried them all of them on Raspberry Pis, and could never get decent results. Then went to the mini server, gave me better results, but still did not do what it was promising, which was it streams to YouTube every time you print. So that would be an awesome plugin for Clipper and Moonraker or Fluid. I would really like that. All right. What are we at? I know we're almost there. Back over to the dashboard. We're at 95%. Temperatures are holding absolutely solid. I think there's maybe, yeah, like 1 degree of variation. Don't think we're going to get much better than that. All right, 51 seconds. 98%. Really curious to see what this top layer is going to look like. And there we go. It's done. All right. Oh, excellent bed adhesion. Okay. All right. I wish we could turn the fans off. We can definitely see. This camera sucks, but you can definitely see where we first turned it up to 200 right there. Noticeable kind of a bulge, but then it seems to go back. And all the way up to 500%, we do see a little bit of error. I believe that was right about 400. There's a little bit of a hole in there, but it could be a filament issue back here on the back as well. You can clearly see a line at each point that we increased it. But then again, it tends to smooth out, and that is more on the x-axis than the y. The y, the first time we can see it, but past that, you really can't see it. Top looks excellent. Little amount of ghosting right here on the leading edge, and a little bit of horning or looping here on the corner, especially once we got we could see it was perfect. And then when we kicked up to 200, that's when we got a little bit this leading edge on both sides. Yeah, you can feel it's a little more round here and a little more hooked on this side. It means we need to tune our pressure advance. That side is not bad. You see a little bit of a difference right as the speeds changed, but yeah, you can definitely see right before the edge. I'm still not sure y'all can see, but print is not quite as clean, but that is not bad. That is not bad. We're sliced at 700, 20% infill, PETG, and then sped up to 500% with no failure. I've never had a printer do that. So there you go. There's why Klipper is so nice. As much as I loved, much like Octoprint, I loved Marlin. It's just that we got to come up with a more real-time configuration. I get how some people say they don't like the configuration time and troubleshooting that goes with the Klipper config, and it is definitely a bit of a headache. There you go. So not just a disembodied voice. It is a bit of a headache the first couple of times you do it. But once it is set, or if you find someone else's profile, it is a game changer for the quality of your prints. Yeah. I have been converted. I am a Klipper file. So there you go. There is an Ender 5. Pretty much $0 upgrades. We just have printed parts. Big Tree Tech E3 version 3 Mini. A 3D touch auto leveling sensor. And that be it for add-ons. And we have noticeably improved the quality of this printer. Very impressed. I'm excited to get back in its home and start running some jobs on it. So I will catch y'all with the next one. And that one we'll probably be doing the Ender 3 Pro into a belted Z. And we'll go on from there. Y'all have a good one.